Hello. So today we have a question from GATE 2024 paper from Statistics and Probability part. The question goes as, let x be a random variable which is given to be exponentially distributed with a parameter lambda. Here lambda is a parameter which is provided that it is greater than 0, strictly greater, and the distribution function is given as f of x is equal to lambda e to the power minus lambda x when x is strictly greater equal to 0 and 0 otherwise. Now the question asks us to find that if 5 times of expectation of x is equal to variance of x, we have to calculate the value of lambda. So in order to find the value of lambda, we need, first of all we need to find what is expectation of x and what is variance of x. So in order to calculate, first we will try to calculate expectation of x. So expectation of x can be defined as integration from minus infinity to plus infinity x into fx of x. Now we can write it as minus infinity to 0 x into fx of x plus integration 0 to infinity x into fx of x. Now here we can easily see that when the range of the function is from minus infinity to 0, fx is basically 0. So ultimately we will have the expectation of x as e of x equal to 0 to infinity x fx of x dx. Now putting the value of fx x, we get integration 0 to infinity x into lambda e to the power minus lambda x dx, where lambda is a parameter, it has to be strictly greater than 0. Now since lambda is a constant value, we can bring it out of the integration and we can write it as 0 to infinity x e to the power minus lambda x dx. Now this is a improper integral, it's an improper integral. Now in order to solve this kind of integrals, we can use the concept of limit. We can modify this integration and write it as lambda into limit b tends to plus infinity integration 0 to capital B x e to the power minus lambda x dx. Now by using the method of integration by parts, we can write lambda into limit b tends to plus infinity x. What is the integration of e to the power minus lambda x? It is minus e to the power minus lambda x divided by minus lambda. So the integral limits I can put it now. I can put the limit from 0 to b minus integration from 0 to b. I have to calculate the derivative of x, and with that I will have to multiply the integration of e to the power minus lambda x dx, and ultimately I have to calculate the integration of this entire product. So now let's try to simplify it. We get lambda limit b tends to plus infinity, this value becomes b e to the power minus lambda b by minus lambda minus 0. Since x, putting the value of x as 0, 0 into something, some positive value, since exponential value is never negative, So 0 into some positive value will ultimately give me 0, minus integration derivative of x with respect to x will be 1, and what will be the integration of e to the power minus lambda x? It is obviously minus e to the power minus lambda x by minus lambda dx. I have to calculate this value. So we can write lambda limit b tends to infinity b e to the power minus lambda v by minus lambda minus I can make it plus 1 by lambda integration 0 to b e to the power minus lambda x dx. So this will ultimately give me lambda into limit b tends to infinity b e to the power minus lambda b by minus lambda plus 1 by lambda e to the power minus lambda x by minus lambda from 0 to b. Now lambda limit b tends to infinity b e to the power minus lambda b by minus lambda plus 1 by lambda square minus e to the power minus lambda b plus 1. Now if we now try to calculate this limiting value, now since b tends to infinity, so we can say that b has a finite value, because here we are putting a limit that b is tending to infinity. So at the end of the day b has a large value, somewhat a large value, but it has to be finite. Now e to the power minus lambda b, if b tends to infinity, then if b tends to infinity e to the power minus lambda b, this value tends to 0. Therefore we, from this line, if we use the limits, we can write lambda into limit b tends to infinity, this particular value, since b tends to infinity, it has a finite value, so some finite value into a number which is very close to 0, the product will give me a value which is very close to 0. So by default we can write this limit as 0 plus 1 by lambda square. By same logic, this limiting value will be 0 plus 1. So ultimately after simplification I will get the value to be 1 by lambda. So this is the expectation of e to the power, this is the expectation of the given distribution. Now we try to calculate the variance of x. We know that variance of x is nothing but expectation of x square minus expectation of x whole square. So in order to calculate expectation of x square, we need to find the integration x square from 0 to infinity. Obviously if we calculate the limit from minus infinity to 0, it will again become 0. So ultimately we have to calculate this limit. So this limiting integration value will give me the expectation of x square. However, we can use one shortcut here in order to calculate this integral, and that shortcut is known as gamma function. We know this is a standard thing. Gamma of n is basically defined as improper integration from 0 to infinity e to the power minus x to the power n minus 1 dx. Now we basically try to put this integration in this particular form, and if this value, if and also gamma n can be defined as n minus 1 factorial, provided n is a positive integer. If n is a positive integer, then gamma n can be written as n minus 1 factorial. So in order to convert this particular function into gamma form, we can do one thing, we can use some substitution. We put lambda x to be t. If we put lambda x to be t, then we get dx equal to 1 by lambda dt. And what will be the value of the integral for t and for x? When x is 0, t will be 0, and when x is infinity, t will also be infinity. Therefore the given integral will get converted to lambda into integration 0 to infinity. X can be written as t by lambda this square e to the power minus t, and dx can be written as 1 by lambda dt. So by further simplification, we can write this as 1 by lambda square integration 0 to infinity e to the power minus t, t to the power 3 minus 1. We can write t square as t to the power 3 minus 1 dt. So basically we find that this form is nothing but the gamma form. So we can write it as 1 by lambda square into gamma of 3. Now what will be the value of gamma 3? The value of gamma 3 will be 3 minus 1 factorial. So ultimately this value will be 2 by lambda square. So we have calculated the value of expectation of x square. Therefore what will be the variance of x? The variance of x will be expectation of x square minus expectation of x whole square. So this will ultimately give me 2 by lambda square minus 1 by lambda whole square. So ultimately we get the variance as 1 by lambda square. This particular two formula of expectation and variance, most probably in order to save time, it's expected that someone who knows statistics and probability distribution, they should be remembering this formula in order to work fast with this. So now moving on to the question. According to the question, we have 5 times of expectation of x is equal to variance of x. That is 5 times of 1 by lambda is equal to 1 by lambda square. So by cross multiplication we get 5 lambda square equal to lambda. So if we bring lambda from right hand to the left hand, we get 5 lambda square minus lambda is equal to 0, which gives, if I take lambda common, we get 5 lambda minus 1 equal to 0. But lambda cannot be 0 because it's, according to the question, lambda is given to be strictly greater than 0. Therefore we should have 5 lambda minus 1 equals to 0, which will give me lambda equals to 1 by 5, which is nothing but 0.2. This is the value of lambda. I hope that this problem is understandable. Any kind of feedback is accepted. So I hope this problem is understandable for everyone. Okay, thank you.